Last time we talked about why LLMs can be manipulated. No trust boundary, remember? Today we are doing through the actual hit list. 10 specific ways LLM powered application get broken, leak data or get hijacked in the real world right now. This isn't theoretical. Every one of these has a real name, a real attack pattern, and a real fix. By the end of this video, you will be able to look at any AI product and immediately spot which of these 10 it's exposed to. Let's rip through it. This isn't a random list that I made up. It's based on the OBS top 10 for LLM applications. The same organization behind the OBS top 10 you already know from the web app security. Just adopt it for AI systems. Some idea, same idea as the classic OBS top 10. The most critical, most common risk categories ranked by real world impact. 10 categories. Let's go one by one. The first one is a prompt injection. This is the one that we have already covered the why and now the how. The direct injection is someone types ignore your instructions straight to the chat. The indirect injection, the scarier one. Malicious instructions hidden inside a web page, an email, or a PDF that the model reads and obeys without you ever typing anything malicious yourself. The mitigation isn't the one thing, it's a layer. Filter input, structure your prompt with clear delimiters, validate output, restrict what tools the model can touch, and monitor for weird behavior. No single layer stops this alone. The second risk is the insecure output handling. Flip side of the same coin. The model's output is untrusted too. Pipe it straight into a web browser without encoding. That's the XSS. Straight into a SQL query injection. Straight into a shell command. Prompt injection. Fixes: treat LLM outputs like user input. Never trust it blindly. Whatever's consuming the model's output, sanitize for that context specifically. HTML encoded for the browser, parameterized for the database. Third risk is the training data poisoning. An attacker doesn't touch your app at all. They poison the data your model or your fine tunes trains on. A backdoor gets backed in before the model ever ships. And it looks completely normal or every benchmark you run. Defense is know where your training data come from and test the finished model adversarially, not just for accuracy. Fourth risk is model denial of service. Remember max token from last video. This is why it matters. A massive prompts, recursive structure, request engineer to generate the longest possible output. All of it burns your compute and your budget. Cap input and output length, rate limit per user, an alert on cost spikes before they become the five-figure invoice. Fifth risk is supply chain vulnerability. Your AI supply chain is bigger than you think. Model weights, training data, embedding models, vector databases, plugins, orchestration frameworks compromise any link, and the whole application inherits the damage. To fix this, treat model weights the way you would treat any third party dependencies because that's exactly what they are. Risk 6 is the sensitive information disclosure. Model memorize things. Sometimes that includes API keys, PII, or proprietary code that leaked into training data. Same way, along the way, and a well crafted prompt can pull it back out. To fix this, the golden rule is never put secrets in a system prompt and filter output for pattern like SSN, credit card number, and API key formats before they reach the user. The seventh risk is the insecure plugin design. Plugins and tools are how an LLM actually does things in the real world. And that's exactly why a badly scoped plugin is dangerous. Accept unsanitized input, runs with admin level permission, no auth. That's the wide open door. To fix it, every plugin should be scoped tight, authenticated properly, and logged completely. The eighth risk is the excessive agency. This is the one that matters most. Once you start giving model real autonomy, issuing refunds, deleting records, sending emails, executing code with no human checking first, one prompt injection, one hallucination, and it's not a chat mistakes anymore. It's a real world irreversible action. Put human in the loop for anything high impact. Design action to be reversible whenever you possibly can. Our ninth risk is over reliance. The human problem, not the model problem. People trusting AI output without checking it, fake legal citation, vulnerable code shipped straight to the production, decision made on fabricated data. Dangerous, specifically because the model sounds so confident while being wrong. Again, to solve this problem, you need to put human review as a mandatory action for anything consensually. Train people to verify, not just consume. Our 10th risk, the last one, is the model theft. Attacker is stealing your actual model weights, or worse, reconstructing your model's behavior just by querying it enough time and watching what comes back. Your competitive advantage walking out the door, one API call at a time. To solve this, you have to log down where weights are stored, rate limit, and watch for extraction shaped query pattern, and watermark output where you can. We have seen the 10 risks, but notice the pattern underneath all of them. Input you can't fully trust, output you can't fully trust, and autonomy that multiplies whenever whatever goes wrong. Everything on this list tracks back to that. Prompt injection and secure output, the trust problem, both directions. Poisoning in supply chain, the attacks happen before you even ship. Disclosure and plugin design, what leak out and what gets too much power. Excessive agency and over reliance, humans and models both trusting too much. Model DOS and model theft, your computer and your IP both up for grabs. That's the map. Next video, we go deep on the one you will fight the most, prompt injection and jailbreaks. The actual attack technique and the defense that hold up against them. If this was useful, hit the subscribe and I will see you in the next one. Thank you.